All right, we're going to go ahead and graph polynomials today and just see where we can get with multiplicity and some different terms like that, and we'll talk about them as we go. So if you look at that function, so first thing we're going to do is just determine the zeros or roots and the multiplicity of those roots. And so if you look at that a there that I have, you have f of x equals x times x minus 3 times x plus 2 times the quantity of x minus 1. So we're going to go ahead and set each, to get the roots, you just set each of those to 0. So x equals 0. You have x minus 3 equals 0. You have x plus 2 equals 0. And you have x minus 1 equals 0. So by setting those to 0, we have all of our roots. So we know one of them is at 0. So I can put that one in. Whoops. Other than I'm a little off. But so 0. If you take a look at this other one, this 3, you'd have to add 3 to both sides. That switches your sign. And so we'd have a 3 root. And I'm off to the side a little bit. So we know x equals 0. We know x equals 3. You do the same with the 2 by subtracting 2 from both sides. X equals negative 2. And you do the last one with the 1 by adding 1 to both sides. And so x equals 1. So those are our 4 roots. Now, let's take a look at these in Geogebra, in the graphing part of it too. So that's just how I'd find my roots quick. And here's just that top graph in green there. This shows you our roots. We've got a negative 2, a 0, a 1, and a 3. And if you notice, the graph comes down here, passes through, then comes back up, passes through 0, comes back down, passes through 1, goes down a ways, comes back up, and passes through 3. And so they just pass right through each of the roots. Now let's change that a little bit. So the next graph, B, has the same roots, but if you notice this x squared, it occurs 2 times. This x minus 3, it occurs 2 times. The x plus 2 occurs 3 times, and this x minus 1, it'd be to the first power, so it occurs once. So that is telling you it's giving you your multiplicities. So in each case, x squared, so that's the 0. If you remember, that was the 0 root. And it has a multiplicity of 2. This positive 3 has a multiplicity of 2. This negative 2 has a multiplicity of 3. And this positive 1 has a multiplicity of 1. And so let's take a look at that graph, see what it looks like when we try it. And here it is. And I'll put it in blue, and we'll get that green one out of there. And you notice here at 0, the first one, they're in kind of an odd order here, but you got 0. It bounces there at 0. So if it has a multiplicity of 2, it bounces off the x-axis. If you notice this negative 2, it has a multiplicity of 3. There's that multiplicity of 3. And if you zoom in on that thing, notice how it has like this little squiggle. So it comes in from above. So again, it comes in from above. It levels out at negative 2 there, and it passes through it too. And if you zoomed in, you'd see that graph passes directly in at negative 2. That's the only place it hits. Everywhere else, it approaches 2, and just right at negative 2 it passes through. And so as you're looking at that, so let me zoom out here. So the multiplicity of 3, it has that little wiggle, I call it. At 0, it bounces off because it's got a multiplicity of 2. at 1 here, it passes through because my multiplicity is 1. And then if you notice here, this looks like a straight line, but it actually, let me zoom in on it, it bounces off at 3, and positive 3, and again, because that multiplicity is 2. So if the multiplicity is 2, it bounces off the x-axis. It touches right there, and then it goes right back up. Multiplicity of 1, it just passes through. Multiplicity of 2, it bounces again. And here, this multiplicity of 3, we get this little flattening out right by the root before it passes through. And so that's that one. Let's take a look at the next one. And so on this one, you've got, here we've got this 3, so now my 0 root has a multiplicity of 3. It occurred 3 times. My x minus 3 occurs 4 times here. This x plus 2 occurs once, so that would be a 1. And this x minus 1 occurs twice. So same roots again, but it's going to change slightly. And so let's pull up those others, that graph. So that's that third one here. And I'll just have to zoom out a little bit. I'm going to, we want to be able to see that, so I'll zoom out, keep zooming out. And so there you have kind of an idea. So that negative 2 there, that root has a multiplicity of 1, you can see. It has an exponent of 1 for x plus 2. This 0, notice it's got that kind of leveling out area. Well, that's because it has a multiplicity of 3. And then the 1 bounces. Let me pull that over there because it has a multiplicity of 2. And the 3, that 3, if you notice, it has a multiplicity of 4. So it bounces, but it has this, kind of like that, as you get your higher and higher powers, that thing levels out more. So like, if we change that to a 6, now, boom, it widens out more and then passes through. And if you change it to, say, a 5, it's going to pass through, but it's going to flatten out and then go through. So let me change that thing to a 5. We'll take a look at it, and there it is. And so the multiplicity determines kind of how your graph looks right at the x-axis. And so that is multiplicity and how that works. The next thing we'll talk about is end behavior and just kind of what it looks like on the extreme side. So if you look at this thing, it says the largest degree of the polynomial, if it's odd, and the leading coefficient is positive, then the graph generally looks like the following. So let me do it. I don't have the graph there for you yet. So in this case, my largest degree is 5. And my leading coefficient is this 3 right here. So that's the leading coefficient, and it is odd and positive and greater than 0. And so generally this graph is going to come up from the bottom, do some stuff, it might, whatever, might do something, and then it's going to leave going up out the top. And so my end behavior is when the largest degree is odd and the leading coefficient is positive, it looks generally like that. It's going to come up from the bottom, do some stuff here in the middle. We don't know what until we make a table or we graph it, and then it's going to exit going up from left to right. And so that's generally what it is. Now, what happens if your leading coefficient is negative and it's odd? So if it's negative and it's odd, it's going to do just the opposite. And so if you take a look at this, my degree is still 5, so we've got that odd degree, but my leading coefficient's now negative 3 because that's your number in front, your number in front of the highest exponent. And so that's going to do just the opposite. It's going to come in here from the top, do some kind of wacky stuff in the middle, depending on the graph, and then exit going down. So your end behavior looks something like this. And we can simplify it. It would come in like this, dotted line, exit like this. So we just don't know. We'll just have to fill in this middle part at a later date, based on roots and things like that. And so that's what we'll do. But that's your end behavior if your degree is odd. Okay, so what about having an even degree? So here, your degree is even because it's a fourth power. So we have a fourth degree here. And then your leading coefficient is a 2, so it's positive. And so when it does that, it generally looks like this. And it'll be dotted here, and then it'll exit this way. So just based off the front number, if your leading coefficient is positive and your largest degree is even, it's going to look like that, where this middle part, we're really not sure what's happening, but our two ends come from above and leave going up. So it's kind of like a happy face. Okay, now the other one down below is what happens then if it's even but your leading coefficient is negative, and you can see that there. So the leading coefficient is this -2. Well, it's exactly the opposite. It's going to be sad. So it'll come in here, dotted, and then leave. And again, this dotted part, that's what we'll fill in later with the roots and things like that. Okay. All right, so let's try it out. Let's put it all together. So the first thing you do is find the zeros of the polynomial. Well, if you remember from the last time we talked about this, we could go ahead and you've got some possibilities with the 6. You've got using the theorem, the rational root theorem, we've got some rational roots. It's either with 6, it's either 2, 1, 2, 3, or 6. With 2, it's 1 and 2. And so your possibilities could be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 1/2, plus or minus 1 again, plus or minus 3 over 1, which we already have, and then plus or minus 3/2, and then plus or minus 6/2. And again, what I'm doing is taking the rational root theorem. If you take your constant divided by your leading coefficient, these are all the possible rational roots we could have. And so I'm just going to try 1 and see what we end up with. And I'm going to use synthetic division to see if it comes out even. And so we go ahead and divide. I'm going to go ahead and divide 1 by the 2, 5, -1, and -6. If you divide that, you've got 2. That would be 2, 7. 7 times 1 is 7. 6. 6 times 1 is 6. So we got 0. So that means 2x squared plus 7x. Sorry, it's a little squiggly there. Plus 6 is my quadratic, which would factor, I think it's 2x plus 3 and x plus 2, if I had to factor that. And so we know we now have 3 roots. I'm pretty sure that's right. 3x, 4x is 7x. Yeah, so that's right. You set each of those to 0. We know x is 1 of my roots, so I'll put that in there. We know 2x plus 3, if you set that to 0, equals 0. So just kind of out of room there on the edge. But you subtract 3 and you divide by the 2, so x is negative 3 halves. So negative 1.5 is another root. So I'll put that one there. And then our final root is negative 2 if you set this one to 0. And so I'll put that one there. Kind of hard to see, but I think we got them. And if I'm graphing these, what I'll always find is the y-intercept. You know, that's the next thing on the list. Well, the y-intercept for this is you just plug in 0. So you'd have 2 times 0 cubed plus 5 times 0 squared. You know, I'm going to run out of room. Minus 0 minus 6. Well, this stuff's all 0, so you just have negative 6. So we know we have a y-intercept down here at negative 6, which so we're ready to kind of work this in and graph it then. So then you go to in behavior, which is this third one, and we know we've got an odd degree and the front number's a 2, so it's positive. So we know this graph starts from down below somewhere. All these multiplicities are 1, so our graph passes through, comes back down to negative 1.5. It's going to go down to this y-intercept and bottom out somewhere, or bottom in front of it. We don't know for sure without making a graph, and then pass through and go on up and out. So this is generally what my graph looks like as a rough sketch. You know, now if you wanted to sketch any highs and lows, you'd have to make a table and plug values in to find out what's going on, you know, in this area here and the area down here at the bottom. And so we're not going to do that, as long as you can kind of generally just rough sketch what's going on. But it's always kind of neat to take a look at that thing. And so here it is, and I just have to zoom out. There we go. There's my root at 1. Getting this thing to fit will be tricky. And that pretty much generally what I had. I mean, this one definitely looks a lot nicer, all computer generated and everything. But it came from below, passed through negative 2, passed through 1.5, went down to, you know, passed through negative 6 for the y-intercept, then came up and passed through 1 and up and out. And so that's a general sketch. So let's look at one more here. All right, last example here. So we've got this polynomial here where it's already factored out for us, and you got x minus 1, x minus 3, x plus 2 squared, and so you set each of those to 0. And so if you we have roots. If we set all 3 of those to 0 at so if you have x minus 1 equals 0, x minus 3 equals 0, and x plus 2 equals 0. So we have roots. This one would be plus 1, this one would be plus 3, and this would be minus 2, because you subtract 2 from each side. You know, just solving the 2. What makes those true. And then the last thing is, you know, multiplicities. So this one, the multiplicity here is 1. The multiplicity here for the 3 is a 1. The multiplicity for the negative 2 is a 2. And so we can graph this thing. So we go ahead and put in our 1. I'll try to do it. I should have got a little bigger paper, or a little bigger graph paper, but here we go. 1. We got a 1 at 3. We got 1 at negative 2. And so we've got all of our roots. Then generally, so this negative is going to make my front term negative. And we got 1, 2, 3, 4 roots. So this is an even. So it's going to come in here. Well, and there I think I made a mistake. Let me look. But here's what I think what's going to happen. And another way you can do this is just test. Like if you just threw in like a 4 into this thing and just see, is it positive or negative? But this thing's going to come in and then swing back out. 1, 2, 3, 4. Yeah, it's going to make, I think, a U shape. But we'll just check. So if you put a 4 here into this thing, 4 plus 2 is 6. 4 minus 3 is 1. 1. There I'd get a negative. Yeah, because of the negative out front. So it does come out through the bottom. So no, I was probably right to start with. But okay, I had it typed in wrong before. But the graph, there it is. You got this positive 2. My video's getting kind of long, so we're going to stop it. So we got this negative 2 here. It bounces because the multiplicity is 2. This 3, it passes through at positive 3. And you've got a negative 1, which is, or a positive 1. So it passes through there. And it is an even, so it comes in here from the bottom and it's negative. Comes in here from the bottom and it leaves through the bottom. So it does match up with your 4th degree. It's a 4th degree with a number less than a negative number for the leading coefficient. And so it makes that little U shape. So that's a 20-minute video.